And let's get started. So, welcome everybody to the EMS seminar series. This is our second one for this semester. We're very happy we have Chad Hansen come talking about the Red Wing Bridge project, a very huge project that has many parties involved. So before we get started, let me give a brief introduction of our speaker today. Chad graduated with a Bachelor of Civil Engineering degree from the University of Minnesota and began his career with Minnesota DOT in 2001. He's a civil engineer with over 19 years of experience in traffic, design, project management, and construction at Minnesota DOT. He's currently a principal project manager in Minnesota DOT District 6 in Rochester, and was the design project manager for the Red Wing project, Red Wing Bridge project. He and his wife Andrea have a 10-year-old daughter, Mary, and lives south of Red Wing. So this project is really great. I would say important for Chad. He has been involved with for many years. So let's get started. Let's welcome Chad. We have a poll here.
All right, thank you. I'm gonna stop my video here just for while I do this, so I don't making sure it doesn't slow down anything. So
sounds good.
Yeah, thanks a lot for having me tonight. I'm just gonna run through a little bit about the Red Wing Bridge project. So I've been involved in this project on about a 10-year period. It's finally coming to fruition now. Construction is getting completed here this year. So I guess I'm just going to go through kind of the overall design process that we went through, kind of right from project inception all the way through final design and into construction. So I took the project over in 2009, the end of 2009, and I pretty much managed it the whole way through scoping, preliminary design, final design, and then I actually stayed on with construction as well for about a year, even though we typically turn that over to our construction staff full time at that time, but I was more of a supportive role at that time. So tonight I'm just going to go over just a general background of the project, and I see a few of you have been across the new bridge. Doesn't look like too many of you, but maybe you have something to go check out now after this. So I'll go through kind of the alternatives analysis and the design process, go over some of the big challenges and risks that we had through the project, some of the things that we learned, maybe we do differently next time. And then I'll finish up going over the cost, and maybe if we do have time, I'll go over some construction photos and then finish up with the schedule. So just to orient everybody where we're at, so north is kind of basically up in this picture. The green alignment coming across from Wisconsin in honor of your Packers. Coming across the bridge is Highway 63. That comes right into the downtown part of Red Wing, onto right in the core of the downtown, takes a right, and it follows one block, and then it takes another right to go to the south down toward, I guess, Lake City, Winona, and on down toward, I guess, La Crosse, eventually down that direction. Highway 58 is a Minnesota trunk highway. That ties into Highway 52, which is a route to get to and from Rochester. So there's about a 1 block section where 58 and 63 overlap. There's a lot of congestion in that one area where those highways come together. And then the yellow alignment is Highway 61, which is also a U.S. highway. And that runs all the way basically along the river, which I'm guessing most of you are aware of that. But that does also overlap with Highway 63. So right in the convergence of all these highways is essentially where the project terminates on the Minnesota approach. So just a little background on the bridge itself. It was constructed in 1958 to 1960. In 1960, when it was opened up, President Eisenhower actually came and dedicated the bridge. Here's a picture of it, probably in that early 1960 era when the center span was being raised up. They constructed both ends and raised up the center span to match that, to how it essentially the final alignment, as you can see in that bottom photo. The overall length of the bridge is just over 1,600 feet. The center span is 432 feet of that. So the approach spans are the remaining 1,200. There's no pedestrian or bike facilities on the bridge. And shortly after it was constructed, I guess shortly in a bridge time span, over the first few years, the north abutment and the piers on the north side settled considerably, and they actually dropped some areas as much as 3.5 feet. So if you can imagine the roadway and the abutment dropping 3.5 feet over time, it's very poor soils, and the foundations were obviously not adequate for what was built out there. And then what really made this project come to the forefront was when the I-35W bridge collapsed in 2007. The Minnesota legislature identified a number of bridges in the state that were on this Chapter 152 program in '08, and it required us to address all of the fracture critical bridges like this around the state. And what we would either have to look at replacing the bridge or doing a major rehab to somehow try to make that make it structurally redundant so it's not fracture critical any longer. There's also a bridge, and if I can go back maybe one slide, this bridge 9103 is where Highway 63 goes over 61. It's a curved bridge out right where it curves into Red Wing. So these two are very interrelated. So going back to that bridge, it's a 5-span concrete slab span bridge. It's saturated with chloride. It exposed rebar. There's spalling. It was very poor condition. We actually had planned to replace this in 2017, but the issue that is with this is it is eligible for the National Register of Historic Places. So that gives it a lot of extra protection and things we have to go through, that it's not simply we can just say it's to the end of its life and we're going to replace it. We have to look really hard at what we can do to rehab it as well. There's also a number of traffic issues that we had to deal with the project. So the bridge itself had just over 13,000 vehicles a day that travel on that, which we knew we had to look at whether or not a 2-lane would be adequate for the long term. We also had to look, there's a fairly high number of trucks that come into Red Wing on 63. Right where my red dot is here, there is a tight corner that trucks have a very difficult time making. And there's a traffic signal that has always been there. The signal poles get hit. They have track over the curb. It's not safe for pedestrians. So that was another issue. Again, where Highway 58 and 63 overlap on that block, there's a lot of congestion there. And then that's also right in the heart of the downtown. So you can imagine all the businesses also see that as a big area where they want to see good parking and, opportunities for pedestrians to move around. As far as the amount of right-of-way, we were very tight constraints. So it was not simply we replace the bridge and we build another one next to it, but we also have very limited right-of-way. So right where these ADM tanks, and ADM is a grain processing facility where they make different types of biofuels. And right where these tanks are sitting is roughly right where the first bridge that was built across the Mississippi River sits, or where that bridge sat is right where the tanks are now. After we built the Eisenhower Bridge, which after it was dedicated by Eisenhower, that's what they named it. They tore this existing one down that was built in 1895, turned the right of way back, unfortunately, and so that's kind of where we're standing at today, I guess, with a very limited right of way between those tanks and our roadway. And on the other side, I could point out is Barn Bluff, which is also on the National Register of Historic Places. It's very sacred to the tribal community in the area. So we're really tight constraints on both sides. Environmentally, we have a NSP, which is Northern States Power, kind of the predecessor to Xcel Energy. In the late 1800s, they had a coal gasification plant right here. It was a dry cleaner later, and that's really been a hotbed of contamination. We have numerous downtown historic districts that are also protected, so making any geometric changes in the downtown is also very difficult because of limits to what we can really do down there and not modify the historic downtown. We have the Red Wing Shoe Plant where Red Wing Shoes started out. That's also eligible for the historic register. We have that ADM facility. We have Barn Bluff. There's actually 6 railroad lines that run underneath the bridge, and then a campground on the Wisconsin side. So not a lot of extra room for replacing a bridge. This, I just wanted to highlight the amount of historic resources that we dealt with. All of the red properties are on the historic register of National Register of Historic Places. All the ones in blue are such as the Red Wing Shoe Plant, all of the downtown historic districts. Pretty much everything in the area was eligible, which gives it the same amount of protection if it's already on the register. And then the other blue was other properties we had to evaluate from that same standpoint. And then quickly, just some other of the issues we dealt with. Again, I mentioned the downtown parking. Maintenance of traffic was a huge issue. The nearest detour is roughly an hour, 30 miles upstream or 30 miles downstream. So you're either looking to go down to Wabasha or up, basically up to Prescott. So there's no real good detour for just shutting this down and replacing it. Pedestrian safety, there's the Mississippi River Trail, which is a high bike interest in the area, very tourist town, and then just the view shed of the bridge in relation to Barn Bluff. It's really on all of the city's materials. They have the bridge in the background with Barn Bluff in it, so they're very attached to the look of how it is currently. So the alternatives analysis is about probably a 4-year process that we went through, and I'm going to try to go through it as fast as I can. It's going to be very high level, but there's really 6 big decisions that we had to make along the way. One was, we need to determine, is this going to be a 2-lane or a 4-lane crossing? We had to determine, are we going to replace or can we rehab that river bridge? And then if we replace it, what type of structure are we going to replace it with? Then again, the bridge 9103, we had to evaluate it. Can we rehab it, or are we able to just go ahead and replace it? And then depending on what we did with both some of the first 4 bullets, that would also tie into are we going to make improvements on the Minnesota approach and in the Wisconsin approach to address some of the safety and congestion issues at the same time. So again, this is very high level. There's years that went into some of this, but if you can follow the timeline on the bottom, it was 2009 is when we really started to do some of the early studies on this. 2010 is kind of when they were completed. I took it over as a project. And then roughly these first 3 years is what it took to get to these two decisions right here. So first we determined that it was a 2 versus a 4-lane crossing. We were able to determine that the 2-lane would accommodate the 20-year forecasts. So we didn't think that it was prudent to spend the additional dollars on the 4-lane. Highway 63 was not planned to be expanded anytime in the near future on the Wisconsin side. So we also thought a 2-lane would work for the next 20 years, which is really what we base our design on. But then if we do build a new bridge next to the existing one, we wanted to make sure we preserve the existing right-of-way where today's bridge sits, so we don't come back in 20 years and we're in the same boat as we are, you know, where we turn the right-of-way back and then we wish we would have kept it. So the decision was to proceed with the 2-lane. We looked at numerous different, next of all, we looked at rehab versus replacement. You know, rehab really wasn't determined. We just could not see that it was prudent to do that. There were significant maintenance of traffic issues. Trying to construct a rehab project while maintaining traffic, really, it bumped the cost up significantly. It posed some serious traffic impacts, having to go down to a single lane when, you know, having a single lane traffic on this bridge for 2 years would not have been acceptable to the community. One other thing I should note is 1/3 of Red Wing's workforce lives in Wisconsin. So all those people have to come across the bridge on a daily basis. So if we're going to try to go down to a single lane long term, you know, there's also emergency response issues with that was a huge issue for the community. We'd be retaining a non-redundant structure and slightly lower construction costs for the rehab, but if you factor in the user costs, it was significantly higher to go with the rehab. And then, you know, other benefits we would really get out of the replacement was we would be able to add a bike and a pedestrian trail, which was pretty important for the, you know, the Mississippi River Trail. There's quite a few bikers in the area, and, you know, just to get them off of riding on the shoulder was very important. And then the one challenge that would pose, though, is the structure depth. So currently, being a through truss bridge, you know, the bulk of the structure is above the deck with all of the, you know, just that type of design. If we look at a new type of design, which is more in line with like a girder bridge or a tied arch, the deck would be that much thicker, I guess, from, you know, the top of the roadway profile to bottom of deck. And since we had to still maintain that same clearance over the river due to Corps of Engineer concerns, the profile of the road also has to come up. So you can imagine tying back into the downtown was very challenging if that profile would go up. So moving ahead, we did decide that we were going to replace it. We looked at several different structure types. There were 7 that we did an early screening of, everything from a cable stayed bridge to an extra dose bridge. We looked at a tied arch, which I have here in the upper left. We looked at a concrete segmental box, which is on the right. and then we looked at a steel box girder bridge. And some of the, maybe if you want to throw Danny, if you want to throw the next poll up there.
Is poll 2 is about species?
There we go.
Here.
Yeah, I would just say go to the next one that was, there you go.
Yep.
So this is not exactly related to what I'm at now, but just so see what you guys are thinking on that. I'll come to this one in a little bit later. Some of the challenges that we did have with the tide arch were it was just significantly more expensive, that much more difficult to maintain long term, and then constructability was also an issue. The biggest thing with the concrete and the steel box girder were pretty equivalent from a cost perspective, but due to the design of a concrete bridge, the deck is actually the girders are quite a bit deeper. So the profile of the road would have come up several feet more. And that it made it very difficult to get tied back into the downtown Red Wing area. So that posed some serious concerns with that one. The other thing that we got a lot of feedback from was from the public and also from some of the environmental agencies was they really liked the sleek look of a steel box girder just because it opens up the river valley more. It allows people to put more of the focus on the river valley, the barn bluff, and they just felt that it fit in better in the area. So for all those reasons, we went with the steel box girder. See, we had as far as the results of our poll, it looks like we had it's pretty close. Butterflies ended up winning, which was not an issue. So you guys are pretty smart. You guys got that one right. I'll touch on this one maybe a little bit later, but this is just a early schematic of what our steel box girder bridge would look like. So advancing another year to 2015, the next year, again, I want to emphasize that this was about a 3-year process that we went through to get through this just on this one decision alone. And I would say that this was probably one of the most difficult parts of the project was just this rehab versus replacement study and trying to determine whether or not we could rehab it or replace it, and if so, what effect that would have on the downtown area of Red Wing. So Federal Highway is very cognizant of some of the historic bridges. So they want to make sure that we did everything possible to rehab this thing, or looked very hard at rehabbing it before jumping to a replacement. The one thing that really led us to the decision of replacement was all of these congestion issues in the downtown. If we were to rehab this bridge, we would essentially be locking ourselves in with that same alignment of Highway 63 coming into downtown Red Wing. We would have no way to correct that without replacing that bridge. And so in the end, the historic significance of the downtown Red Wing area was found to be more significant than the bridge itself. So we were able to use that argument to show that we had to replace the bridge and put the roadway on a new alignment. And this is the new alignment we ended up coming up with. Again, this is an early visualization, but this is really what it turned out to be. So coming across from Wisconsin now, instead of putting all of 63 traffic into the downtown, the 63 traffic follows the red alignment out to Highway 61. Coming from 61, you have to take the red alignment to go back. There's also a 1-lane exit on this yellow alignment that still allows people to come into the downtown, but it gets rid of gets the trucks out of that downtown. It eliminates that overlap of the two highways. That was the big congestion issue. The Wisconsin approach was a much simpler decision. This is what we arrived at. Currently, this is just an at-grade intersection with roadway only on the upstream side, which is this one right here. We ended up coming up with an alternative. We put a median across that intersection and put in a jug handle intersection. So if you're coming from Red Wing, you take a right, you go wind along here, go underneath the bridge, and then coming back, come up the opposite side, and you take a right here. So it eliminates the left turns from the intersection. So that was our final alignment there. Again, here just shows the different routes. So once we got through the alternatives analysis process, we jumped into preliminary design, which did overlap some. And this was really the result of our the preliminary design. So you can see it replaces the bridge. We were able to shoehorn it in between the existing roadway and the ADM property. It's extremely tight, some tall retaining walls, but we were able to fit that in there. The bridge right on the upstream side of the existing one, the jug handle on Wisconsin side, and then what we're calling the button hook intersection out here, and the slip ramp into the downtown. So we also did a visual quality process to help define what the actual look of the bridge was going to be. Some of the aesthetic features. We put together a committee. Just wanted to show this slide on here. This is something innovative that we had never done before, but it really helped out with our stakeholder engagement. A lot of the, us engineers were used to looking at layouts and bridge designs and design plans. Very, very difficult for the public to comprehend some of that. So what we did was we actually did 3D printings of the bridge, and then we would bring it to the committee meetings, get feedback from the committee, and then essentially real time we could modify it, print out a new model, come to the next meeting, and present our new aesthetic options at that meeting. So it did work very well for public engagement. So just some of the few things that the visual quality committee helped come up with. We ended up putting spires on the bridge that are a little bit unique, maybe to point out here. You can see this is the one. There was one on Wisconsin, one on each side of the road on the Wisconsin side, and then there's two over here as well. So we have the state names are actually on the face of these spires, and they actually illuminate at night. We've got overlooks. We've got two overlooks on the upstream side of the bridge. This is a concrete form liner, but it was made to look like limestone. And then they also help to define some of the lighting that we're putting on the bridge, the colors, a few other elements like that. Maybe if you want to go ahead and launch the next poll. I'll keep going here. All right, so move that out of here again. Sorry about that. So the final design timeline, this is just something you can see 2015 through 2016, 2017 is when we really put together the final design plans. And we hired a consultant to help out with, putting together the roadway plans, telling the contractor, actually how to build it, putting together our special provisions, and then our construction estimates. So the consultant did that. They also designed our approach bridges. We have a new bridge over Highway 61. And there's also another bridge that is right on that slip ramp that I talked about to provide access to the back of the Red Wing Shoe property. So they also designed that bridge, and then all of our retaining walls. Our MnDOT bridge office actually designed the new river bridge. They did all the plans and special provisions for that. And then we did let the project as one plan set. So my job was, as project manager, kind of help to pull all these pieces together and, dealing with the public engagement and more or less coordinating to, keep this thing on schedule, on budget, and, keep it on within the scope that we had agreed on during preliminary design. So I'll touch on a few of the some of the lessons learned and some of the bigger risks. I could probably spend all night talking about some of the challenges on this one, but I think 5 of them really stood out to me that I hope are a little bit interesting here. The environmental, the geotech, the bridge construction, the maintenance of traffic, and then some utilities issues. So again, I've showed you this before, but this is just, some of the historic properties in the downtown, some of the environmental issues. So we, as a part of the preliminary design process, we also did an environmental assessment, and that is, they really go hand in hand. So as you're going through preliminary design, you're also going through your environmental review process. And right at the culmination of preliminary design is essentially your signed geometric layout. And at the same time, or within, a reasonable, within months of that being complete, you would also have your environmental document approved. So those two really go hand in hand. But again, we have numerous contaminated properties with that coal gasification plant, all the cultural resources, historic issues, numerous endangered species, mussels, we have bats, eagles, there's wetland and floodplain issues we had to deal with. So here's a picture of the coal gasification plant that is right through the property where we wanted to put our new button hook alignment. The new alignment, Highway 63, goes right through where this property was. And this is a picture from the early 1900s. So we took over 50 environmental borings in this area to determine what chemicals were in the soil. The soil was extremely contaminated with benzene. There was various other chemicals that are highly regulated that we had to clean up. It had gotten into the groundwater in this area, and the estimate was it would cost over $1 million to clean this site up. So we worked with the Pollution Control Agency and to get more or less to get protection before buying this property, because we knew it could be a huge liability issue long term if we're buying this, taking this on, and then having to clean up some of what was out there. So this actually had to go all the way up to the deputy commissioner of MnDOT to approve the acquisition of this property. But in the end, we felt it was a big enough benefit to Highway 63 and the area that it was warranted to purchase that. We also have northern long-eared bats, which are endangered. So the U.S. Fish and Wildlife requires us to only do tree clearing from November to March when they're not roosting. So we had to let a separate contract out from the big construction project and do a separate tree clearing contract in over the winter time. Unfortunately, when we came to cut the trees down, we found a nice big old bald eagle nest here, which are also protected. So we had to work with the Fish and Wildlife Service, and they put we had to get a permit for cutting some of the trees down in this area. We never did cut the tree down where the eagle was roosting, but you know, we actually had to have we had to hire a person to sit out and monitor the eagle's nest during construction. And anytime we were working within 660 feet of that nest, we had to have a monitor on site to make sure that, you know, if the eagle left for more than like 2 hours, we had to stop construction and wait for that eagle to come back. They just wanted to make sure it wasn't abandoning its nest. We also had vibration concerns with the bluff. There's constantly rock falling from the bluff throughout the year, and especially during the winter and in the spring and in the fall when there's, you know, freeze thaw going on. And then also working by the ADM tanks was a concern, you know, not wanting to cause vibration in the area that would cause anything to leak. So we hired a geotech consultant, and they did a vibration study of the bluff, just to make sure that, you know, not only from traffic and worker safety, but really that historic significance, that we weren't doing something to damage it beyond what's already happening out there. So we did a vibration study, and then we ended up using the results of that to set vibration limits in the contract. So you can see these vibration monitors that we had out there. You can see right in here, this is part of it. It's tied in right in this area. The solar panel, and then we've got a vibration monitor right here monitoring while the construction was going on to make sure that it didn't exceed what was recommended. As far as some of the geotech issues, you can see here, so we had a layer of sand, and then we have the biggest issue. We have about 40 feet of organic silty clay. So you can imagine that's not real good for building a bridge on. All that clay and muck, and the muck is actually in the upper, 40 feet as well, interspersed in that area. And there's a layer of gravel, sand, and the bedrock really varied anywhere from 60 feet here on the Minnesota side, and it really slopes downward as you go across the river to right where our abutment was proposed. It's more about 140 feet deep. So we did, a lot of borings to determine what was appropriate for the new bridge foundations. Pier 1, which is the one closest to Minnesota, was going to be, we built that on two 10-foot drilled shaft foundations. So you can imagine a 10-foot drill bit drilling down 60 feet to bedrock, and then we notched that into the bedrock as well. Out in the middle of the river where Pier 2 is, we set that on 4 9-foot diameter drilled shaft foundations. So we drilled down roughly 80 feet out in the river with 4 different foundations, put steel casing down to the bedrock, filled it up with rebar, and then essentially just filled them up with concrete. So that's what the bridge is sitting on. Piers 3 through 6 in Wisconsin, those are on steel H-pile foundations driven down to bedrock. Most of those were down over 100 feet deep. And then the bedrock was much shallower on the Minnesota side, like I said. So those approach bridges and the retaining walls that we built over there, they're actually just sitting on spread footings. Again, I mentioned some of the poor soils on the Wisconsin side. It's basically just a marsh area over in this area. And this is right in the area where that roadway had settled. And, you know, again, we did a lot of boring in that area. What we ended up doing, though, to address that, to make sure we did not have the settlement issues that we did with the first time the Eisenhower Bridge was built, we actually excavated out several feet of the muck, and then we built it up to the final roadway profile. And then on top of that, we built another 5 to 10 feet of surcharge of additional sand that was placed on top of that final roadway profile to help consolidate that soil and get it to compact in a more accelerated, more accelerated, I guess, so we could take care of that settlement. Then we put in a lot of wick drains, and maybe if you want to go to the next poll, I guess the answer to the last one was it is the Eisenhower Bridge of Valor. So for those of you who chose that, that's what that one was. All right. I don't know if you want to go to the next poll. All right. And then the wick drains are really a vertical drain that help that water come up vertically. So as that soil is compressing, essentially it's forcing that water up through these vertical drains, and we had to let that surcharge sit on there for a 12-month settlement period before we could, you know, remove that surcharge and then pave over the top of that. So here's just a picture of some of these wick drains. This is the machine they use to put the wick drains down. And it's more or less just a plastic sleeve. You can see there was, I can't even say how many hundreds or thousands of these there were that they put in, but it took a long time to get all those driven in. So the answer to the last one was 1.5 million pounds of reinforcement bars in the river bridge itself. There was several more million pounds in the steel box girders, of course, but this is just the rebar that was in the concrete, was over 1.5 million pounds. All right, so the wick drains. Utilities, I'll just touch on this one real quick. I know we're getting to the end here. We did initiate a utility survey early on. Typically that would not be done until later, but fortunately for us, this black alignment, we were able to locate that, and it's a high voltage line that runs right under where that button hook ramp would have to go. So we were able to get that relocated in advance. And if we wouldn't have done that early utility coordination, you know, it likely would have delayed the project. All right, so the final poll answer was 175,000 feet of wick drains. So do the math there. If it's down, you know, 60, 80 feet or more, that's a lot of wick drains. So if they were out there, here's them relocating the utilities. I think maybe the last thing I wanted to touch on here. So span 1, constructing over the railroad. Normally we would put up a crane down here, right where these tracks conveniently sit. But we did meet with Canadian Pacific early and often throughout the project, and they made it very clear from the beginning that they were not going to give us any track outages, which more or less means they're not going to stop their trains for us to build our bridge. So more or less figured out a way to construct the bridge while the trains are still allowed to operate through there. So what that resulted in was really having a flagger out there over a 2-year period where we built our bridge. We met with contractors and did constructability reviews. And, really what we found was that our regular way of erecting that span was not going to be possible. So what we ended up doing was something that's never been done in Minnesota before. We did a bridge launch. And this is, obviously not the one in Red Wing, but this is an example how it was done on another project. We have this launching frame, and then they have the box girders more or less sitting on land. They slide them out onto that launching frame, out onto the pier. So it's more or less they have a counterweight on the back side, and they slowly cantilever it out and slide it out till it gets onto that pier. And that's essentially what we ended up doing to construct that. MOT, I guess this is the last here before construction, but we ended up deploying or using a temporary bridge. The new alignment overlaps with the existing bridge. So even though now we're putting a tangent bridge slightly offset from the curved bridge, they did overlap some, so we ended up tying it into a temporary bridge in order to construct that button hook and allow traffic to be maintained throughout construction. So at no time throughout the project did we have to shut this Highway 63 down. All right, so completion of the design process. Our final estimate for the project was 95 million construction cost, or I'm sorry, our funding amount for construction was 95 million. Our final estimate came in our district was 84.5 million. Our central office does an engineer's estimate, which is based on the final plans. They had it at 72.8 million. And when we actually opened up the bids, we had 5 bidders on it. And the bids came in at $63.4 million. So that was a good day. It was a big surprise, but the steel prices had actually dropped significantly right before bid opening. So we were able to get some benefit out of that. The contractor that we ended up getting was quite a bit lower than the next one. So the other ones were, some of them were $10 million in excess of what our low bid was. So we ended up getting a Wisconsin company out of over by Milwaukee. I think they're out of Waukesha, maybe. Zenith Tech ended up being the prime on this one. So with that, I don't know, are there any questions that people want to ask out there? Otherwise, I can, if not, while we're doing that, I can breeze through some of the construction photos while people have questions.
Yeah, Chad, how about you just continue on the construction update, and then if we have questions, we will put into the chat box.
All right, that sounds good. Yeah, feel free to interrupt me if any questions come up. So I'll just go through some of these. So here's the building the causeways. This is the Wisconsin side. Building the causeways to get out to construct the piers on the Wisconsin side, right through the muck. Here is us doing the some of the excavation to get the muck out of there, showing us building up that surcharge and the new jug handles. Here's that surcharge in play, or I guess here's where it was when it was up to the final grade of the new roadway before we put the surcharge on 63. But we also had a surcharge over here on those new jug handle roadways that tie in. So you can see these, there's tarps here on the side where that surcharge was, was wrapped in that. Here's where we're building our new piers on the Wisconsin side. Again, here's the photos you'd seen before on the wick drains. Some of the sheet piling. So while we excavated that muck out of there, we had to support the existing roadway of Highway 63. This is just showing we had driven steel piling all the way along Highway 63 to support that while we excavated that muck out and until we got it built back up and then that surcharge put on. Here on the Minnesota side, this is us cleaning up the lovely coal gasification plant. Some of the goodies we found buried in there. Some nice surprises that we came across that we had to haul away. Here's constructing again some of the button hook, some of the new Highway 61, 63 alignment down in this area. Here's building the retaining walls, and here you can see this is the room where, here's the walls right along ADM. They had their own wall. This is their tanks. So this is the right of way from the existing Eisenhower Bridge to the ADM tanks. And so we're building a retaining wall right up to their retaining wall, just wide enough so we could drive a maintenance vehicle in between the two walls so we can access underneath the new bridge. So you can see basically from where this wall is up to the existing bridge, that's where our new roadway is at. And then this is also another retaining wall we built on the Minnesota approach. So here's the river bridge itself, which is Bridge 25033, which is the Eisenhower Bridge of Valor now. Just building some of the caissons, so to give us a dry working area before they pump the water out of here. This is while they're driving. On the left, you can see them driving the steel H piles. And then on the right side, of course, the piers are starting to be raised up with the rebar and as they're pouring some of the concrete. Again, the piers, some of the pier work on Wisconsin side. Here's the abutment on the Wisconsin approach, right over in this area. Here is our drilled shafts. So here's our drilling rig. You can see it's drilling in the casing, but they've got that. This one is out in the middle of the river, so this is a 9-foot diameter drilling bit they're going down. And here you can see two of the drilled shafts. And here is after they have been filled in with concrete with some of the reinforcement bars coming out of them. And this one on the right is actually the Minnesota approach, because this is the two 10-foot diameter ones. And then in the midst of construction, of course, we have flooding, which happens in this area quite frequently. This is that campground that I mentioned earlier on where we're building the new piers that totally got flooded out, totally flooded the work area. So we, this happened, I guess it was the second construction season, caused delays throughout the summer because of that. This is just showing the placement of the the beams on the Wisconsin approach, which are 82-inch depth pre-stressed concrete beams. The steel box girders are only the center or the main 3 spans over the river. The rest are the pre-stressed beams. Here is just the box girders being fabricated. They were fabricated in Eau Claire, Wisconsin at Veritas. So I went up to the factory and we had people up there inspecting them. I just went up there one day to visit it, check it all out. But it's pretty cool to see inside a factory. They had the whole 432 feet end to end of the building. It basically ate up the whole length of the building, the box girders, when they were all assembled. And then what they do, they basically take them apart, haul them on trucks, and then bolt them back together once they arrived at the work site. Again, here's them assembled. Here on the right, you can see them with a large machine moving them out to take them over to do the priming and painting on it. I'll just finish up. So here's raising the box girders, splicing it in. Just shows some of the splices. There's 5 splices on each one of these girders, 1 to 400 bolts in each one of these splices. So there's, thousands and thousands of bolts splicing it together. Here is the final one being placed on the right, the final girder. The guy on the left putting in some of the bolts. Here's our final lighting, what the aesthetic lighting looks like at the end. And the ribbon cutting ceremony, which was last October. So if you remember the bridge when it was erected in 1960, how it was raised up, this is kind of the mirror image, only now we're lowering it down onto barges. 60 years later, just almost to the day. So here's some stats. We took down about 3.8 million pounds of steel that was cut up and hauled away. The bridge was, 40 feet tall. We lowered that center span in one piece, which was about 800,000 pounds. And then once it was removed, we basically demolished the piers and cut them off 2 feet below the bottom of the river. So with that, I guess that's about all I have. I've got the letting. Groundbreaking was in May of 17. The button hook and temporary bridge opened in 18. The river bridge was completed at last October. And then in 2020, we hope to have all of the construction complete. Roadway work, all the final cleanup by the end of this year.
Well, thank you so much, Chad. I really want to go there now. So I haven't been there, but look at the picture, look at those all the construction photos. Make me really want to go there. To check it out. So thank you so much. Well, I do have some questions up here from the chat box. So the first one is, did the final estimate include any future maintenance cost?
The final estimate was construction cost only, so that did not include any maintenance.
I agree. Yeah. Were barges ever an issue during the construction?
No, we had to maintain that to keep that channel open. We tried to do most of the work over the winter time when that barge season was down or when the barges were not going, but we were hoping to have all of the box girders raised up over the winter time, and it actually, due to some of the flooding delays from the previous season, we weren't able to get all of them down or get all of them raised up before the barge season opened up last, or I guess it was a year and a half ago roughly. So we did have to work in between barges when some of them, the final girders were placed. So yeah, we worked very closely with the Corps of Engineers to you know, make sure what would work with them would work with our construction.
Right. One more question here. I think this is an open-end question. What would you have done differently if you had the ability to make changes to the town?
To make changes to what?
To the town of Red Wing, I would say, to the town. So,
What, any other changes to the town of Red Wing
yep,
in this area?
yep.
Um, you know, the one thing that it would have been, I don't think that I have control of the change, or I know I don't have control of this change, but there were a few things in the downtown, in the historic area, where we would have liked to maybe expand the roadway a little bit more and provide additional um, pedestrian and bicycle facilities. We really had our hands tied because where those curb lines were at, they had to stay. We were not allowed to alter the curb lines, any of the corner radiuses. We actually had a city park in the one corner. So there was, you know, really in that downtown, we had our hands tied. So there wasn't a lot we could do. But if I had if it was up to me, I think there was a few other improvements we could have made ideally, but I think the way it turned out worked just fine. So.
All right. Okay. So that's all the questions I have from the chat box. Any other questions from the audience? If you have any, please unmute yourself. Otherwise, it's 6:03. I want to honor the time here. So if you have other things to do, go ahead and then, feel free to leave. Otherwise, I believe chat will stay we will hang out here. If you have any questions, you feel free to ask. Again, thank you very much, chat, for your time to introduce this bridge to us. Really amazing. Thank you.
All right. Yep. Thanks for having me.
Yeah. So any other questions from the audience? No? All right. So anyway, Chad, I have one question very quick. So when you see the surcharge to bring to the final elevation of the road, did you have to move the surcharge away, or that becomes a part of the roadway?
No, we placed the surcharge on that. We actually had several surcharges. We had surcharge under US 63. We had surcharge under where those new jug handles came in. And then we had a surcharge. We replaced a box culvert further to the north on 63. And all of those required a surcharge. So we placed the surcharge. It sat there roughly 12 months. I'd say roughly, because one of the areas we got by with a little bit less. But then at the end of that settlement period, we came in and we removed that surcharge, hauled all that sand away, and some of it we were able to use in other parts of the project as fill. But yeah, we removed all of that and then got down to the final roadway profile.
That's about, you said, how deep is that? 3 feet? The surcharge?
The surcharge was 10 feet deep.
10 feet deep. Okay.
Yeah.
All right. 10 feet.
It was way up. Yeah, it was a significant surcharge.
That's a lot of sand to haul back and forth.
Yes. A lot of sand just for extra compaction, temporarily. But yep.
Okay. Yeah, so we have a question here asking about the certificates, because this do have the PDH hours. I will send an email to everyone, all the attendees, about how to get the certificate. So I will send an email tomorrow because I have the list of the attendees. So I will reach out to you. Yeah, don't worry about the PDH hours. Yeah, so one more question here says, did they have to relocate wetland after taking wetland away? Does the project occupy any wetland?
Yep, we had both temporary and permanent wetland impacts. And so we had to work with the Corps of Engineers has jurisdiction over that. We also dealt with the DNR on this one, but it was generally the Corps of Engineers that they have jurisdiction over wetlands. And so we did have, like I said, temporary and permanent impacts. How they determine what mitigation you have to do is kind of the quality of the wetlands. And so based on the quality of the wetlands that we were impacting, they determined a ratio of replacement. And I think it's generally, I think on this project, it was a ratio of 1.5 to 1. It was somewhere in that range. There was two different ratios that we had to meet for mitigation, but more or less we have to find replacement wetlands, you know, more than what we impact.
Okay.
And so in Minnesota, in our district, we actually have a wetland bank. So we have created a large area we bought on another project over a decade ago, and we created a huge wetland area, and we can use credits from that to apply to other construction projects. So that's what we did on this project. So they don't require that you replace them in the same area.
Right.
You just need to replace them.
Somewhere else is counted too. Okay.
Yep. And actually they say sometimes that is preferred, because if you're creating a tiny little wetland just to try to fit it into the project, sometimes it's better to create one large one that's more of a larger benefit to species. So.
Well, after you mentioned about this, I have a question similar to this. You know, you mentioned about the eagle nest. That you have to hire someone to watch for it for 2 years, and then
yeah.
I mean, I don't know. You know, I'm not a biologist. Can we just move that nest to somewhere else?
I know, that's kind of how a lot of us felt. I think it was a pretty easy job for that guy for a while, but
I mean, I think they can learn, don't they?
Yeah.
Can't they learn to go to their new home? You know, kind of relocate project. You know, we're gonna take care of them for sure.
Yeah.
But, you know, it's just like houses. We have to do some relocation projects. So
right.
Well, just for my curiosity, I would say.
Yeah, I know. It was the biggest area was, you know, when we're clearing the trees, when we had to deal with that, because that's when we were working the closest to that nest. But anytime we had construction while that eagle was around, then we did. It was primarily in that first year, but you know, yeah, there were a lot of environmental issues on this, and I just touched on them. Like I said, I mean, we had to, you know, they had to go diving for mussels, and we did, you know, incidental take permits for the mussels in the river, and yeah, so.
Awesome. Well, so we still have a couple of people hanging out here. Any questions from you guys? Robert, I saw you are here. So, any questions from you guys? Otto, Sam, so you're all here.
All right.
Okay, well, so I think, yeah, there's no other questions. Again, thank you so much. I really, really appreciate that. You know, I found this project down there, you know, just completed recently. So, you know, that's so close to us. And then we are so happy to hear about more details. A lot of times, you know, when you see the surface of it, right? You don't appreciate how much work have been put in there.
10 years of my life, it was.
Yeah, there are so many things being put into there. You know, consider different things. Oh, yeah, I had a very question. I remember it. I want to ask you, when you decided are we gonna do a two lane versus 4 lanes, right? So the study said, okay, in the coming 20 years, this 2 lane bridge should be fine. So does that mean, let's say if you look at, you know, 50 years in the future, maybe 20 years later, are we gonna put a lot of 2 lanes side by side? Because right now we took down the old one, right? So will that be the new location, the location for the additional 2 lanes when the time comes?
So that's what Oh, it's echoing. There we go. Better. Yeah, that's what we're making sure that we preserve that right of way. So when we tore the old one down, we're gonna hang on to that right of way. And we actually designed a layout for 4 lanes to make sure that it would work, and we weren't, tying our hands so we wouldn't be able to expand in the future. So the new 4 lane, whenever that is warranted, say if it's 20 years, 40 years, or whatever, we have designed it so it could go back where the existing bridge was at. And then that button hook, how it comes over to curve around to tie into 61. That is also designed so on the inside part of that button hook, we could fit the future 4 lanes.
Awesome. Awesome.
Yep.
Cool. So the 4 lanes will, in the future, as you said, the design will be separate then. The 2 lane and the 2 lane will be separate.
Yep.
Almost like 2 bridges.
There'll be 2 structures,
Right,
exactly.
like 2 structures. Okay.
Yep. There'll be 2 structures over the river and 2 structures over 61.
Okay. Awesome.
Yeah.
All right. All right. Okay. So let me see. Do we have one more question or not? Thank you. No other questions. Thank you for the presentation. Yeah. Okay. So, well, yeah, I don't have any questions. The only thing I want to do is I want to go drive up there sometime. Next time when I go to St. Paul, I definitely will drive through there, because when I go there, that's one route to go through. So I look forward to it.
Yeah, you have to walk across the new trail, so check
Yeah,
that out.
and then the bridge right now has sidewalk and then bike lanes, right?
Yep, it's a 12-foot trail across the river, so
Nice.
yeah.
Nice.
Actually, the trail isn't open. The bridge is open for vehicles, but the trail isn't. So
why?
they're
still
still doing some painting, and
Okay.
they have equipment on it right now.
Okay,
so.
that's why you say that the project is not completed yet. The full
Right.
project. Okay.
There you go.
Okay. Awesome. Well,
All
thank you
right.
so much. Thank you so much, Jack. Chad. Well, I'm gonna stop right here, and then we will